Hello everyone, welcome back to my channel. In this video I'm going to be taking you through circular measure at AS level. And so one of the most important things that we need to understand under this topic is that all angles are measured in radians. Alright. All angles are measured in radians. Right? And in radians, the standard measurement is pi. Standard measurement is pi, and pi stands in for 180 degrees. Right? So there will be cases where we will have to convert angles from degrees to radians, and for that we just multiply whatever value of the angle we have in degrees by pi over 180. For example, if we are asked to convert 60 degrees to radians, we'll just go on and say 60 degrees times pi over 180, like this, and we get a third pi radians. So this will be the size of this 60-degree angle in radians. And from this we need to understand and be able to use the two formulas that were given under this topic, which are the one for area of a sector, which says half r squared theta, and the second one for the length of an arc, which is simply r theta. And these two are provided in the formula booklet that you're given in your exam. So there's really no need for you to try and remember them, but it will be helpful to do so. And there are also several theorems that we need to keep in mind under this topic. The first one being the one that says if you have a circle and a tangent like this, the radius of that circle meets the tangent at 90 degrees, or in other words, the radius is always perpendicular to a tangent that it touches. So let me just write that down. The radius, or a radius rather, a radius is perpendicular to the tangent that it meets, right? And the other one is an angle in a semicircle is 90 degrees. So if we have an angle that is subtended by a diameter like that, say this is our center here, and this is obviously our diameter. So if the diameter is subtending an angle at the circumference, that angle is always 90 degrees. Right? So then we write an angle that is subtended at the circumference by, in a semicircle, let's start with in a semicircle, in a semicircle by a diameter is 90 degrees, right? So you want to get questions asking you to state this, but this will come as part of questions where you need to record this, that the radius meets the tangent at 90 degrees, and if you're given a semicircle and a triangle inside with one of the sides being a diameter, you can then use this. So just by knowing this, you can then go ahead and use stuff like the Pythagoras theorem, where you find sides, this being your hypotenuse, right? And if you have another angle here, which we can call theta, you can say this is your adjacent and this will be the opposite. And you can only do that by understanding this. This is why I'm stating it. And the other one, let me draw it out first. Say if you have a circle and you have two tangents to the circle, lines that just touch the circle without cutting through it, like this. And if the two tangents meet, two tangents to the same circle meet, for example here at point P, these two are equal. From this point that they touch the circle to the point they meet, they are equal, right? So if this is A and this is B and P, we would be saying AP is equal to BP, like this. I hope you have understood that. And moving on to the next part, which is trigonometry. Under this topic, you're also expected to recall certain concepts of trigonometry from your IGCSE, which are, of course, your trig of right angled triangles, which most of you might remember. That if you have a right angled triangle, this side that is opposite, the 90-degree angle is our hypotenuse. And let's say we had an angle theta here, this would be the adjacent, and the side that is opposite this theta will be our opposite, right? And so we can use our tan theta to be opposite over adjacent, and our sine theta to be opposite over hypotenuse, and lastly our cos theta to be adjacent over hypotenuse, like this, right? And that is for right angle triangles. And we also need to remember the Pythagoras theorem, right, which also falls under right angle triangles, to say if this side is C, this B, and this A, or C squared is equal to A squared plus B squared. So like I said, you don't necessarily get questions specifically on this, but it will be part of questions under circular measure, where you need to apply this, right? And the last one being the trigonometry of non-right angle triangles, triangles that do not have the 90-degree angles. So let's name our triangle A, B, C, and the sides, let's use lowercase letters A, B, and C, like this, right? So the first one being the sine rule, we state that A, for example, over sine the angle at A, which will be this one, right, is equal to B over sine the angle at B, which is this one, which is also equal to C, the side, over the angle at C, sine the angle at C, like this. So you can use this when you're given, let's say, two angles and one side in an attempt to try and find the other side. For example, let's say we're given this angle and this one and just A. We can use this to get B, because we'll be having the angle at A, the angle at B, and A. So we can make an equation and get B. But in a case where you're not given an angle, you're only given sides of a triangle, a non-right angle triangle. Let's name it A, B, C, A, and our C. We can then use the cosine rule, which states that our side C squared is equal to side B squared plus A squared minus 2BA cos the angle at C, which is this angle. And with this, we can make cos C the subject if we want to get the angle C. So use this when you're given the sides only and none of the angles, right? And making cos whichever letter you assign, you can get one angle first, and from there you can work your way out, right? And so these are the things that you need to remember under this topic, and you should also be able to apply them on questions that come.